Hi there, science fans, and welcome to Fact Tank. Have you ever wondered why the sky is blue, or how microwave ovens work, and why soda fizzes? Get ready for some mind-blowing facts and let's embark on this awesome journey of scientific discovery together. Alright, Fact Tankers, let's dive into our first head-scratcher. Why does ice float? You might think, well, ice is solid, shouldn't it be heavier and sink? And you wouldn't be alone, but hold on to your beakers because the answer lies in the fascinating world of density. Density is all about how tightly packed the molecules are in a substance. Think of it like this. Imagine a dance floor. If the dance floor is packed with people, it's more dense, right? Now, in liquid water, the molecules are free to move around and bump into each other like a room full of energized dancers. But when water freezes and turns into ice, something amazing happens. The water molecules form a crystal lattice structure, kind of like a well-organized dance party where everyone has their own designated space. This structure actually spreads the molecules out, making ice less dense than liquid water. Now you might be wondering, if ice is less dense than water, why don't ice cubes just float in the middle of my glass? Well, they would if they were perfectly balanced. But here's the thing, even though ice is less dense overall, the bottom part of an ice cube is still slightly denser than the water around it. This means that while most of the ice cube wants to float, that tiny bit at the bottom is trying to sink. It's a constant tug of war. And because water is so good at pushing back, we see ice cubes floating with a little bit submerged and a little bit sticking out. Now, let's take this to the extreme. Icebergs. These massive chunks of ice are like giant ice cubes, and because of that density difference, only about 10% of an iceberg's mass is actually visible above the waterline. That's right, folks, the saying tip of the iceberg is no joke. The vast majority of an iceberg, a whopping 90%, lurks beneath the surface. So next time you see a picture of an iceberg, remember, there's a whole lot more to it than meets the eye. Okay, science sleuths, let's unravel another everyday mystery, the marvelous microwave oven. We pop our leftovers in, press a few buttons, and bam, food's hot in an instant. But have you ever stopped to wonder what's going on inside that metal box? Well, it all comes down to a special type of energy called electromagnetic radiation. Now, before you start picturing superheroes and gamma rays, let me explain. Electromagnetic radiation comes in many forms, including radio waves, visible light, and yes, even microwaves. Microwaves are a type of electromagnetic wave that falls between radio waves and infrared radiation on the electromagnetic spectrum. These waves have just the right amount of energy to do something pretty amazing. They can make water molecules vibrate. Now, you might be thinking, okay, vibrating water molecules, that's cool and all, but how does that heat up my food? Well, picture this. Imagine a crowded room full of people all trying to dance to different tunes. That's kind of what's happening inside your food when those microwaves hit. The water molecules start jiggling and bumping into each other, creating friction. And just like rubbing your hands together generates heat, this molecular friction causes the temperature of your food to rise. But wait, there's more. Microwaves can also do some pretty wild things under the right circumstances. For example, did you know that you can create plasma using grapes in a microwave? I know it sounds crazy, but it's true. When two grape halves are placed close together in the microwaves become trapped between them. This concentrated energy excites the electrons in the grapes, causing them to break free from their atoms and form a state of matter called plasma. Now, while this is a cool science experiment, I strongly advise against trying it at home. It can be dangerous and potentially damage your microwave. Have you ever looked up at the sky on a clear sunny day and wondered, why is it blue? The sun's light looks white, right? But the answer lies in Rayleigh scattering. Sunlight is made up of all the colors of the rainbow. When it enters Earth's atmosphere, it collides with tiny air molecules. These molecules scatter blue and violet light more strongly. Our eyes are more sensitive to blue light, making the sky appear blue. Isn't that neat? So the next time you gaze up, remember the beautiful dance of light and air molecules. Ah, soda. That bubbly, refreshing beverage that many of us enjoy. But have you ever stopped to wonder what makes that satisfying fizz when you crack open a can? It all starts with carbon dioxide, or CO2, a gas dissolved into the liquid under high pressure. When you open the can, the pressure drops, and CO2 escapes, forming bubbles. The rough surface of Mentos provides nucleation sites, causing a dramatic eruption. So, enjoy your soda, but maybe leave the experiments to the professionals. From the satisfying fizz of soda, let's move on to another culinary wonder, the making of bread. Have you ever watched in awe as a lump of dough magically transforms into a fluffy loaf of bread? That transformation is thanks to yeast, a tiny microorganism. Yeast consumes sugars and produces carbon dioxide gas. This gas gets trapped in the dough, causing it to rise. The more gas produced, the fluffier the bread. So, next time you enjoy bread, appreciate the science behind it. Have you ever noticed that, after a long bath or a swim in the pool, your fingers look like prunes? It's a common phenomenon, and for a long time scientists thought it was simply due to osmosis, water moving into the outer layer of your skin. But it turns out, the answer is a bit more complex and fascinating. You see, our bodies are incredible machines constantly adapting to their surroundings. And this wrinkling? It's not just a passive reaction to water. It's an active response controlled by our nervous system, our body's electrical wiring. When your fingers are submerged in water for an extended period, your nerves send signals to the blood vessels in your fingertips to constrict or narrow. This constriction reduces the volume of your fingertips, causing the skin to wrinkle. But why go through all this trouble to wrinkle our fingers? Well, scientists believe it might have to do with grip. Just like the treads on your sneakers help you grip the ground, these wrinkles might have helped our ancestors get a better grip on wet objects. Think about it. If you're an early human foraging for food in a stream, having a better grip on slippery rocks or wet plants would be a huge advantage. It's like having built-in rain treads for your fingers. And studies have actually shown that people with wrinkled fingers can handle wet objects more easily than those with smooth fingers. So next time you're washing dishes or taking a dip in the pool, remember that those wrinkles aren't just a funny quirk. They're a reminder of our amazing evolutionary past. Now you might be wondering, if it's so beneficial, why don't our fingers stay wrinkled all the time? Well, there are trade-offs to everything. While those wrinkles might help with grip in wet conditions, they also reduce our sensitivity to touch, not ideal for dry land activities. So our bodies have evolved this clever system to give us the best of both worlds. Wrinkles when we need them, smooth fingers when we don't. Isn't the human body incredible? Yawning. We all do it, from tiny babies to the tallest basketball players. It's an involuntary action like sneezing or blinking, but unlike those reflexes, the reason we yawn is still a bit of a scientific head-scratcher. We have some good theories though. One of the most popular theories is that yawning helps regulate our brain temperature. You see, our brains are like powerful computers, and just like computers, they work best at a certain temperature. When we yawn, the act of stretching our jaws and taking in a big gulp of air might help cool down our brains. Another theory suggests that yawning is our body's way of getting a quick oxygen boost. When we're tired or bored, our breathing can become shallow, which means we're not taking in as much oxygen. A big yawn forces us to take a deep breath, flooding our lungs and brains with a fresh supply of oxygen. But here's the thing about yawns. They're contagious. Ever notice how just seeing someone yawn or even talking about it can make you yawn too? That's because yawning is also thought to be a social behavior, a way of communicating with others. Scientists believe that contagious yawning might be a form of empathy, the ability to understand and share the feelings of others. When we see someone yawn, it triggers a similar response in our own brains, as if we're mirroring their behavior, and studies have shown that we're more likely to yawn contagiously when we see someone we know and care about yawning, compared to a stranger. So the next time you catch yourself yawning after a friend, it might be a sign of your strong social bond. Now I know what you're thinking. You're probably yawning right now, aren't you? See, I told you it was contagious. But hey, don't fight it, embrace the yawn. It's just your body's way of keeping your brain cool, your oxygen levels up, and maybe even connecting you with the people around you. So, the next time you yawn, don't be embarrassed. Think of it as a fascinating scientific mystery, and a testament to the incredible complexity of the human body. Onions. They add flavor and complexity to countless dishes, from savory stews to crispy onion rings. But let's be honest, they can also be the bane of a cook's existence, turning even the most seasoned chef into a teary-eyed mess. But why? What is it about these humble bulbs that makes our eyes water? Well, it all comes down to chemistry, my friends. Inside every onion cell there's a potent mix of enzymes and sulfur-containing compounds just waiting to be unleashed. When you cut an onion, you're breaking open those cells, releasing those compounds into the air. One of these compounds, called syn-propanethyl S oxide, is the main culprit behind your tears. This volatile gas is released into the air and quickly makes its way to your eyes. Once there, it irritates the sensitive nerve endings in your corneas, the clear outer layer of your eyes. Your brain interprets this irritation as a threat, and what does your body do when it senses danger? It triggers a defense mechanism, tears. Your tear ducts kick into overdrive, producing a flood of tears to wash away the irritant. Now you might be thinking, Bill, I love onions, but I hate crying. Is there any way to avoid this culinary conundrum? Fear not, my fellow onion enthusiasts. There are a few tricks you can try. One simple tip is to chill your onions in the refrigerator for about 30 minutes before cutting them. Cooling the onions slows down the activity of those pesky enzymes, reducing the amount of irritating gas released. Another strategy is to cut your onions under running water. The water helps to dissolve the gas before it reaches your eyes, sparing you from those stinging tears. And if all else fails, you can always invest in a good pair of onion goggles. Those might look a little silly, but hey, no shame in protecting your peepers. So, the next time you're chopping onions and feel those tears welling up, remember it's not a sign of weakness, it's just chemistry in action, and with a few simple precautions, you can enjoy the flavor of onions without shedding a tear. Have you ever noticed that on a chilly day, touching a metal surface feels way colder than touching wood? I'm talking about a park bench, a metal railing, even a doorknob. Brrr! It sends shivers down your spine, right? Well, it all comes down to the science of heat transfer. You see, everything around us, including our bodies, is constantly exchanging heat energy. Heat always flows from a warmer object to a cooler one. So when you touch something colder than your hand, heat energy transfers from your skin to that object. Now here's the key difference. Metal is a much better conductor of heat than wood. Think of it like this. Imagine a racetrack. Metal is like a superhighway for heat energy, allowing it to zoom away from your hand quickly. That rapid heat loss is what makes metal feel extra cold to the touch. Wood, on the other hand, is more like a bumpy dirt road for heat. It doesn't transfer heat as efficiently, so the heat from your hand doesn't flow away as quickly. As a result, wood feels relatively warmer, even if it's the same temperature as the metal. Materials like metal, which are excellent heat conductors, are often used in situations where you want to move heat quickly. Think about cooking pots and pans. They're made of metal because they need to transfer heat efficiently from the stovetop to your food. On the flip side, materials that are poor conductors are called insulators. They're like those cozy winter jackets that trap heat and keep you warm. Wood, rubber, and even those fluffy marshmallow-like materials used in winter coats are good insulators. Now, here's a fun fact. This difference in thermal conductivity is why touching metal in winter feels much colder than touching other materials, even if they're at the same temperature. Remember that park bench on a frosty day? It's not actually colder than the wooden bench next to it, but it sure feels like it because of how quickly it draws heat away from your hand. So the next time you reach for a doorknob on a cold day and get that brrr feeling, you'll know it's not just the temperature but the amazing science of heat conduction at play. Hiccups, those sudden involuntary spasms that seem to come out of nowhere. We've all been there, right? 1 minute you're enjoying a nice meal, the next minute, your diaphragm throws a little party in your chest. But have you ever stopped to wonder, why do we hiccup? It all starts with your diaphragm, a dome-shaped muscle at the bottom of your chest. When you inhale, it contracts and flattens, creating space for your lungs to expand. When you exhale, it relaxes and moves upward, pushing air out. A hiccup happens when your diaphragm gets irritated or excited. It's a sudden involuntary contraction, causing your vocal cords to snap shut, creating that hic sound. While the exact reasons are still a mystery, common triggers include eating too quickly, drinking carbonated beverages, and stress. Most of the time, hiccups are just a minor annoyance and go away on their own. But in rare cases, they can persist for days or weeks and may require medical attention. So, if you have persistent hiccups, consult a healthcare professional. Fun fact, the longest recorded case of hiccups lasted 68 years. Luckily, such extreme cases are rare. So next time you hiccup, remember the science behind it and maybe have a chuckle. Well, there you have it, explorers. From floating ice to fizzy drinks and those pesky hiccups, we've uncovered the amazing science behind some of the most common occurrences in our daily lives. It's incredible how much science is packed into every single day, isn't it? Which of these everyday science facts surprised you the most? Let us know in the comments. And hey, speaking of everyday mysteries, have you ever wondered about those common myths we hear all the time, like cracking your knuckles causing arthritis? Well, get ready to debunk some myths, because in our next video, we're diving into the truth behind those everyday misconceptions. Stay curious.